Homework 3.3, Polynomial Division, Factor Theorem, Remainder Theorem, Video 4. Homework due Wednesday, May 27th at 11:59 p.m. The following video will correlate to questions 6, 7, and 8 in the homework. In the first three videos, I showed you how to do polynomial division. Polynomial division using the long division approach, which will always work and is always long. That's why it's called long division. But there are some polynomial division problems that you can do much more quickly, much more efficiently, in much less space under the right conditions, and that process is called synthetic division. So I'm going to show you how to do synthetic division using this particular example, and you may recognize that this is the same division problem as in the first video. So when we get to the end, you might want to go back and make sure that we got the same answer as before. We will. But before we jump into the synthetic division process, I need to tell you when you can and can't use it. Well, if I tell you when you can, then otherwise you can't. So when can you use synthetic division? When does it work? Synthetic division only works if the divisor, the part you're dividing by, is one of two things. X plus a number, I'm going to say x plus c, or x minus a number. And that's it. You can't have any variation on this. There can't be more than two terms. The x can't have a power on it. The x can't even have a coefficient in front of it. Well, okay, the coefficient is 1, so let's say that. So, you can only use synthetic division if the divisor is a first degree binomial whose leading coefficient is 1. Or more descriptively, x plus a number or x minus a number. This one is. This is x minus a number. This is x minus 2. Now, this first example is going to take longer than you would normally do synthetic division because I'm explaining all the parts of it, the setup, the work, and how to get your answer from the work. So in the next video, when we do another example of synthetic division, you'll see just exactly how efficient it is. All right, synthetic division has three components to it. The first component is the setup. And the setup has two parts to it, so an A and a B. Now let me kind of describe what it's going to look like when it's all said and done. I'm going to draw a box here. There's going to be a number in there, and there's going to be some numbers to the side of it. In fact, when it's all said and done, you will have 3 rows of numbers. You'll have 2 rows of numbers separated by a horizontal line from a 3rd row of numbers. To the left of the top row, there will be a box. Now, almost every math book I've ever seen doesn't actually use a box. They use half a box, or a backwards capital L. I prefer drawing the whole box because I'm going to refer to the number that goes in the box as the box number. So keep in mind, we'll have 3 rows when it's all said and done. To the left of the top row will be a number in a box. All right, here's the setup. The top row equals the coefficients of the dividend. So in other words, you look at the polynomial you're dividing into, and you rip the coefficients out of it from left to right. So for example, the coefficient of x cubed is 1. The coefficient of x squared is 2. The coefficient of x is negative 5. And you even bring down the constant term, which is a 2. So basically, you get rid of all the x's and focus on the numbers. That's actually one of the driving motivations behind synthetic division, is to not look at the x's, but only look at the numbers to do the work. So again, the top row is the coefficients of the dividend, 1, 2, negative 5, and 2. The second part of the setup is the box number. And the box number comes from the divisor, but it's not the numbers, it's not any of the numbers that you see. The box number is the opposite of the constant term in the divisor. So in other words, you look at your divisor, which is either x plus a number or x minus a number. You look at that number, and you put its opposite here. So since the constant term in the divisor is a -2, in the box I'm going to put a +2. Why do we change the sign? Well, in short, do you remember in long division, every time we subtract, we change all those signs before we can combine things? This one change takes care of all of that. So instead of changing every sign after every time you multiply in long division, you change this sign once and only once. It's the only sign change you have to do. So the box number is the opposite of the constant term in the divisor. That's all there is to the setup. So essentially, we've removed all the x's. The second part of synthetic division is the work. And just like the setup, the work has two parts. That being said, I'm going to put A, B, and C. C is just going to say repeat. When you do the work in synthetic division, you have to shift from thinking about just rows to thinking about rows and columns. Every number in the top row, except the box number, represents a column. And I meant to say when you write these numbers in the top row, you want to leave them spaced out a little bit, because if they get too close, you might accidentally fuse them together. Like you might accidentally think that this is a 12 instead of a 1 and a 2. So leave some space between them. The work in synthetic division moves from left to right. You start in the first column, and eventually you'll wind up in the last column, the leftmost column to the rightmost column. But you only do two moves. You just repeat them. In the first column, you add. Now you might be thinking, add what? There's only one number in the first column. I know, you don't see a number here, so I guess if you really wanted to write one there, you could put a 0. Most books will say just bring down the first number. The only reason I say add is because that's what all the other columns were going to do, so we'll say, for the sake of consistency, add up the first column. There's only one number in it, so its sum is that number. After you add, your next move, multiply diagonally by the box number. After you add, you're going to multiply diagonally by the box number. Now when I say diagonally, we're going to go up a row and over to the next column. So it's going to put us right there. And when we go that direction, you multiply by what's in the box. So 1 times 2 is 2. Add, multiply. Then you just repeat. You repeat until you add the last column. Repeat until you add the last column. So, now that we're in the second column, we're going to add. 2 plus 2 is 4. After you add, you multiply diagonally by the box number. 4 times 2 is 8. And then you add. -5 and 3, -5 and 8 is 3. And then multiply diagonally by the box number. 3 times 2, I missed a negative somewhere? No, I didn't. 3 times 2 is 6. And then the work ends when you add up the last column. 2 plus 6 is 8. And I should mention that drawing any of these arrows is not actually part of the process. That's just part of the instruction. You don't have to draw the arrows pointing to the rows or the arrows pointing to the columns or even the arrow pointing the direction that you multiply by the box number. That's for instructional purposes. But of course you're welcome to draw them. And the work is over. Now, if you're thinking this is weird, consider what you would be doing if this were a long division problem. You would be dividing the leading term of the dividend by the leading term of the divisor, writing that quotient as the first term of the quotient, Multiply that term in the quotient by all of the divisor, write it underneath the dividend, change all the signs, combine like terms, bring down the next term in the dividend, and then repeat until it's over. But here the only work you do is add, multiply, add, multiply, add, multiply, add. Much easier work, much more consistent. Oh, and one other thing. I made up this gimmick, I'm so proud of it. When you're adding, you're going in this direction. And when you're multiplying, you're going in that direction. So what's the gimmick? The direction you go when you're adding is half of a plus sign. The direction you go when you're multiplying is half of the times sign. So literally, as you're tracing out the direction to go, you are drawing half of what you should do. Down is half of a plus, diagonal is half of a times. I'm so proud of that gimmick. Oh, wait, we're not done. Because all we've done is taken all the x's out of the problem, did some setup and some adding and multiplying, and now we've got a new row of numbers down here. But this was a polynomial division problem. I'm expecting a polynomial answer. All I have are a bunch of numbers. You start synthetic division by taking out the x's. Guess how you end it? You put them back in. The third and final part of synthetic division is the answer. And like everything else, it has two parts. The bottom row of the coefficients of the quotient, but lower the degree by 1. Now what does that mean? Well, before I divided, I had a third degree polynomial, x to the third. When I took out the x's, they started with x to the third. When I put them back in, I got to lower that degree by 1. So if it used to start with x to the third, now it's going to start with x to the second. So this first number in the bottom row represents the coefficient of x to the second power. Now I don't have to write the 1 because it's implied, but for emphasis, there it is. And then your powers just keep going down. So this is the coefficient of x to the second, this is the coefficient of x to the first. Since it's positive, I should put the plus. Right before you get to the end, you should run out of x's. This 3 is the constant term and it's positive, so it's plus 3. What about the 8? Well, the last number is the remainder. So like in long division, we can append the remainder to the quotient by putting it on top of the divisor and adding that fraction to the rest of the answer. This one is not necessary. I was just emphasizing that the powers are decreasing. This one is not necessary. I was emphasizing that the bottom row represents coefficients except for the last number, which represents the remainder. If you're not accustomed to synthetic division, it does take a little getting used to, but I promise you, it doesn't take that long to learn, and once you learn it, you'll never want to do long division if you don't have to. And sometimes you have to because you cannot always use synthetic division.